Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 6I. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundations and GI Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for the questions and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session, Dr. Bimal Patel. Sir is an associate professor in the Department of Information Technology at CSPIT, Gujarat, India. He has published more than 23 papers in reputed journals and international conferences. His areas of expertise include the Internet of Things, denial of service attacks, large language models, mobile ADHOC networks. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Is my voice audible?
Yeah, sir, it is audible.
Thank you so much for inviting me. I think all the best to all presenter. We all can continue. Thank you.
Thank you so much, sir. So we'll be starting with the papers now. First, we have Koshal to present his paper titled AI powered pharmaceutical inventory management system. Are you there?
Yes, ma'am.
Yeah, you may please begin with your presentation.
Okay, ma'am. I will share the screen now.
Yeah. Koshal, are you sharing the screen?
Yes, ma'am. Yes, ma'am. One second.
I think still screen is not visible. Is my voice audible?
Yeah, sir, it is audible. Kushal, are you sharing the screen?
Ma'am, it's showing connection problem, ma'am. One second.
Madam, we can continue with the next one if it's
Ma'am,
possible.
Yeah, we can continue with the next one till then,
okay.
if you are facing any kind of issue.
Ma'am, can
What?
can my co-author share the screen, ma'am? I will explain.
Yeah, he can. So we can
Okay, ma'am.
schedule your presentation next. So please be prepared.
Okay, ma'am. Okay.
Next, we have Rashmi to present the paper title An Efficient Vedic Multipliers Implementation Using Pre-Computational Logic. Rashmi, are you there?
Yes, ma'am. Am I audible?
Yeah, you're audible. You may please start with your presentation.
Is my PPT visible, ma'am?
Yeah, I guess it is visible. Yes, it is visible. You may please start.
Okay. Okay. Am I audible and the screen is visible now, ma'am?
Yes, it is visible. Please start.
Good afternoon, one and all. My name is Dr. Rashmi Saman, and I am from Sri Madhva Vadiraj Institute of Technology and Management. My paper ID is 1344, and the title is an efficient Vedic multiplier implementation using pre-computation logic. These are the contents which I am going to discuss during my presentation. First of all, when coming to the introduction, in last decades or two, we have witnessed a rapid evaluation of technological world with the introduction of fast processors. Accordingly, the system architecture demands better development in terms of technological advancement. This can be achieved by concentrating on basic computational units like adders, subtractors, multipliers, and dividers. In the present work, we have focused on the multiplier block, which is the main building block of almost all the processors which are used for the various image and signal processing application. In the existing multiplication or multipliers, add and shift operations or shift techniques are utilized. which will improve the area consumption, but it will negotiate the power consumption. So main the challenges are speed and power. So one of the so there is a need to develop such efficient multipliers, which is overcome, which will overcome the speed and power constraint. So one of the best solution is Vedic mathematics, which will offer not only speed as well as it will consume the less power while computing the complex calculation. In the proposed work, we have used Urda Triambakam Sutra, that is UT Sutra, in shortly we can call UT Sutra, which will interpret the data from mutually a top-down or the lateral perspective, vertically crosswise, which serves as the fundamental basic concept within the Vedic mathematics. And this approach will not only give the diverges from the conventional multiplication method, which is basically contain carrying the digits and execute the series of intermediate computation, which will thereby increase the speed. And we have used pre-computation logic as well, which is used to optimize the logical computation. And before we need the before we get the final sum, this logic will optimize the switching activities of the partial production and turn off the main circuit block whenever it is not at all used for the computation purpose. We have developed two designs. In the present work, we have used two Vedic multipliers, and these are implemented using standard 180 nanometer cadence design compiler as well as 40 nanometer uh, synopsis design compiler. So this is the traditional multiplication method which we are used, which we are represented with the help of dot diagrams. Since in the previous research or the existing system implementation, the multiplier designs have been conducted across various abstraction level, such as technological, circuit logic, or physical domains. Fundamentally or basically, this multiplication viewed or represented as a series of repeated addition in which the multiplicand and the multiplicand is the number being added and the multiplier indicates how many times it is added, and the resultant sum in term as the product, which come from consist various partial products, and this will lead the this will lead to lower speed and more power consumption. So this Vedic multiplication. In the present work, we have mainly focused on useful factor to reducing the generation of partial production method and the summation or accumulation of partial product. These are the conventional techniques.
Rashmi, your voice is coming from a distance. Can you?
One.
Yeah.
Now, ma'am.
Now it's good. Kindly continue.
Okay. These two figures are representing the previous or the existing binary counter based multiplier architectures, which are built with the help of full adders. And this will take the propagation, this will consider the propagation delay, thereby using the 8-bit computation, or here, as we can see the circuit, uh, full adders are cascaded, and carry signals must wait for the carry to propagate from the inputs to the output. So, which in turns increase the power dissipation, power consumption, as well as area, as well as delay. So, this design provides a clear and reliable method, but in turns it will cost the delay and power. So these counters are used to operate adding the bit values while managing carryover operation, ensuring the sum remains within the designated bit width constraint. So to overcome the drawbacks of these multipliers, we have come up with Vedic multiplication method, that is UT based computation, where we have three main steps which is involved to perform the UT based computation, which is basically vertically crosswise multiplication. There we have made three steps. In the first step, we will multiply the two numbers in the right hand column. Then we will crosswise multiply those digits in the both columns, and then we will add the uh, column, add the products. Then we will vertically multiply these digits, and we will add those left hand column to the final sum. So with an example, if we explain, we have two numbers over here, 82 cross 72. We will perform the vertical multiplication among these two numbers with right hand column. So if we consider 2 and 4 right hand column, it will provide you 8 at the units place. It will then again crosswise multiplied with the uh, sum of that particular tens place, that is 8 cross 4 plus 2 into 7, which is equal to 46. 4 is carried over here with the multiplicand, that is 82, which will provide you 468 as the sum, total sum. Finally, the vertical multiplication will be performed in the left hand side of the column, and the 4 will get added as a carry, and again we will multiply 8 into 7, which will give you 56 as the product. Then that 4, the previous 4 carry will be get added to that particular sum, which will provide you total final sum as 60,468. But if you are considering that 4 as a carry, the final sum will be 60 and 68, 6,068. Uh, for example, for the 8-bit or the 4-bit computation, we have used this formula where x3 to x0 and y3 to y0 are two binary numbers for the multiplication. As a result, we will get 8-bit, or the multiplication will lead you to which will exceed than 4 bits. Those products will be represented as P3 to P1 and carry as C3 to C0. The generalized formula is given here. With this particular example, we have designed the first 8-bit UT based multiplier, which is Vedic multiplier, with this particular diagram, where we have used uh, first block for the partial product generation, then comes the pre-carry logic, then comes the XOR logic. This is the example. For the same design, we have the block diagram like this. Overall, this equation describes the sum and carry generation in the multi-input adder using 7 cross 3 counters, which is used, which is represented with the help of these formulas. This is the main implementation circuit which are realized for sum and carry of 3 input using XOR and MUX computational logic, which will increase the computation speed, specially developed for this
Sorry
particular
to interrupt you,
work.
but you have 1 minute to conclude your presentation.
Okay. Overall, this is a combination of full adder, half adder arrangement, which will efficiently combine sum and carry signals from the previous stage, reducing the multiple partial carries into the final sum. Similarly, we have designed to specially designed for 4-bit multiplier. So we have analyzed the result based on these three formulas, which will provide you the percentage delay from and improvement from the conventional design. So basically, when with respect to power delay area, we have tabulated this quantitative analysis based on delay, leakage power, dynamic power, uh, and total power, area, everything. Totally, if we are considering PDP, which is better than the existing system. Similarly, here also, using Synopsys tool, we have implemented the same design and we have compared all these parameters. The total PDP is less for the proposed design compared to existing techniques. Similarly, here also, overall, we are getting 29.62% reduction in the PDP, that is power delay product, compared to the existing multiplier, and we have a small area overhead. But these constraint is considered while writing a behavioral Verilog code, and we have reduced that particular delay as well as area with the help of pre-computation logic, and we got 20.74% improved delay as well as the total power consumption of 10.99 percentage of uh, power optimization. Overall, the uh, developed or the proposed multipliers are giving 10 to 30% percentage of optimization, and also it is confirmed that the developed multipliers are efficient in all the three constraints, which are area, delay, and power. These are the simulated results for the conventional as well as the proposed design. Here we can see the RTL level uh, view of both conventional as well as the proposed Vedic multiplier uh, simulation. After that, we have developed the Vedic multiplier with the help of physical design verification, and we have observed that using pre-computation as well as Vedic mathematics, we have developed high-speed multipliers, reduced power computational blocks, and which can be further integrate as a low power unit in the processor block. And in the future, we can work on extended number of bits, as well as we can include some other low power techniques called dynamic voltage scaling, operand isolation scheme, and further we can optimize the partial product generation of carries, which will enhance the overall processor performance. These are the references. Thank you.
So much for your presentation. Sir, do you have any questions?
Fine, fine. Thank you, Rasmiji, for sharing the presentation. Just one question. Have you gone through a
Yes, sir.
literature survey part? You have not mentioned
Uh,
the reason
I
for
have
selecting a Vedic. You have shown directly that
way.
you are going for Vedic.
Yes, sir. Yes, sir. Because I haven't used the existing techniques, because I have gone through so many papers. There they have used add and shift method instead of Vedic mathematics. But Vedic mathematics will uh, give the alternate solution to reduce the complex calculation.
I hope you have added that
So
part in case of
only
research.
only yes, yes, sir. This is the traditional
Fine, fine,
method,
that's fine. Because
existing
from that
method.
only we should be able to find out that these are
Yes,
the
yes, yes.
limitations of other multiplier, and that can be a reason for going for Vedic.
Yes, yes, yes.
Thank you so
Fine, fine.
much for your
Here we
presentation.
have
Thank you.
concentrated.
So we'll be
Okay.
moving on to the next. Next, we have Kushal to present his paper titled AI-powered pharmaceutical inventory management system. Kushal, are you ready now?
Yes, ma'am.
Yeah, please share your screen.
Okay, ma'am.
Yeah, you may please begin with your presentation. It's visible.
Okay. Respected Chairperson, honorable judges, and esteemed faculty members and dear friends, good afternoon, everyone. My name is Kushal P, and I'm pleased to present our project titled AI Powered Inventory Management System, which has been presented at 10th International Conference on Information and Communication Technology for Competitive Strategy, ICTCS 2025. So, this work is carried out under the guidance of Dr. Pavitra A. Simam, along with my co-authors Jeevan S. Hegde, Nagarjunam, Sanjeev Kulkarni, and Manjunath K. So next slide. So what do you mean by a pharmaceutical? So what's the reason behind our project is. So, pharmaceutical inventory management system plays critical roles in hospitals, pharmacies. It ensures the timely availability of medicines, minimize expired stocks, and controls operational system. However, the traditional inventory management system faces several serious challenges. So, what are the serious challenges? Are demand for medicine in highly variable and unpredictable. So, reordering planning is often inefficient, and manual data entry leads to human error. So, because of this issue, pharmacy frequently faces stockouts and overstocking and financial losses. So, this is where we can use AI and predictive analysis to make a sufficient difference by improving the forecasting accuracy, reducing wastage, and automating critical decision. Next slide. So the motivation behind this project comes from the real world problem faced by hospitals and pharmacies. So hospitals loses lakhs of rupees every year due to expired medicines. So and manual system are time consuming and error prone. So there is no unified platform that handles forecasting, reordering, and expiry prediction together. So the studies which we have gone through from for many years, the AI driven automation can improve accuracy by up to 40% and reduce the workload by nearly 60%. And next slide. So what our problem statement is to mainly focus on to maintain the optical stock level, because demand in non-linear and unpredictable, and expiry dates causes unavoidable wastages, and supply delays disputes availability, and a manual system lacks analytics intelligence. So no integrated frameworks for uh, forecasting, reordering, and expiry analysis. So to build an intelligent and automated AI based system that predicts the demand, prevent wastage, and maintain accurate inventory level in real time is the main objective behind this project. Next, next slide. So the objectives are to design an AI powered inventory management for hospitals and pharmacies, and to implement
Sorry to interrupt,
AI.
Kushal, you can shift to directly the proposed method and probably the result analysis that you have done.
Okay,
Otherwise, we won't
okay,
be able to
okay, sir.
complete.
Okay, sir. Okay, sir. Proper system architecture slide. So this is the system architecture slide, sir. So we have different options, sir. Yeah, AI forecasting layer and reordering layer, expiry protection and analytic layer. So we there will be a so you can see that there will be a different management level where you can see the difference in where you can there is a AI forecasting, smart reordering, and drug interaction. Next slide. So this is one of the result which we have shown here, sir. The inventory management module. So here Here, this module provides real-time tracking of medicine, including drug name, batch number, stock quantity, expiry date, and supply details. So user can update, add, delete, search items, ensuring the stock visibility and reduce manual errors. Next slide. So another one is expiry and wastage management module. So this module highlights the uh, medicines that are approachably expiry, display remaining days, batch numbers, and quantity, uses color coded indication for risk level, enables timely actions like redistribution of early usage. So this significantly reduces expiry drug wastage and financial losses. Next slide. So this is where analytics takes place. So analytics dashboard shows top consumed drugs and usage trends and seasonal demands pattern. So user can filter dates, export data, and view graphical insights. supporting better planning and budgeting, sir. And so it's the and advantages of this is advantages like next next next. So advantage of this is a real-time inventory automation, highly accurate demands and forecasting, reduced uh, expired stock and lower purchasing storage cost, improved supply selection, user-friendly interaction, and data-driven decision. So a disadvantage, next slide. So disadvantages is require clean and continuous data. Initial setup is very high, sir, and LSTM module requires periodical restraining, and SQLite is not suitable for large scale hospitals, and some users require training. And conclusion. So the AI-powered inventory management provides a robust and intelligent and automatic solution for pharmaceutical stocks. So this improves forecasting accuracy, reduce wastage, and ensures drug availability and strengthens decision making through real-time analytics. This project clearly demonstrate how uh, AI can transfer traditional pharmacy operation into more efficient, reliable, and cost efficient. So thank you, sir.
Fine, Kushal. Just a suggestion. I think it's probably a project that you're doing.
Yes, sir.
So you are a third year, fourth year student.
So we are building a app like with different layers, like I showed, no, sir.
Fine,
Inventory
understood,
management.
understood.
Okay,
But what you
okay.
can do, you need to refer the research papers.
Yes, sir. We have research up to
And the
30.
second suggestion I can give is probably instead of going for building a project or something like, you can build a agent. Nowadays, there is a concept of AI agents.
Okay, okay, sir.
So that probably you can find out and research it on. You need to call the AI agents and accordingly they can manage whole inventory related to the medical
Oh,
part. That can be a
oh,
smart.
yes, sir.
Right?
Yes, sir.
Thank you.
Ah,
Thank you.
thank you, sir.
Thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have Nitamba to present the paper titled Assessing Adults' Familiarity with Interface Agents. Are you there?
Yes, I'm here. I'm here.
Yeah.
Can you hear
Yeah,
me?
you may please begin with your presentation.
Okay,
Yeah, I can
thank
hear
you.
you. You may please start. Yeah.
Okay, let me share my screen.
Yeah.
Can you see my presentation?
Yeah, it's just getting shared.
Okay, so
Yeah, I can see your screen now. You may please start.
okay, can I start? Okay, thank you very much. So I'm Ntima Mabanza. I'm going to present my paper. I'm from Central University of Technology, Free State in South Africa, from Bloemfontein, South Africa. So my paper is entitled Assessing Adults' Familiarity with Interface Agents. So this is basically the skeleton of my presentation. So I'll start with an introduction, research question, methodology, data analysis, and then findings, and also I'll end with a conclusion. So as we all know, we are living in a digital era whereby technology is becoming part of our everyday life. So we've seen that there have been adoption of interface agent in various field or domain. Some of example of this domain include e-commerce, entertainment, health, education, tourism, customer assistance. So if I take one example, let's say in education, in health, you find that you can interact with a virtual doctor to assist you with your health problem. In entertainment, we've seen that there have been adopting cartoons and animals to play the role which human beings have been playing. So interface agent, that the definition is a computer application that is autonomous, capable of emulating human-like communication and behavior to enhance human technology interaction. So there are different terms which have been used if you're referring to interface agents. Anthropomorphic interface agent, conversational agent, embodied agent, and I'm not going to name all of them as you can see there, so for the sake of time. Okay, so adults, which is the focus of my research here. So adult is a person, the definition for adult is a person who has attained the age of majority. So basically the age of majority is the age whereby someone is able to do his citizenship duties, to vote and make his own decision and so forth. So if you are talking about the age of majority, it differ from country to country. In the case of South Africa, the age of majority is defined from 18 years. 18 years is recognized as the age of majority. That's in the context of South Africa. So again, when it comes to technology, it's well known that adults frequently adopt new technology with reluctance. They are hesitant to adopt new technology. That's basically the characteristic of the adults. So there are different factors which can influence that thing of, being reluctant to the technology. Probably they have insufficient digital literacy skills. It can be anxiety about privacy breach. It can be doubt regarding system dependability. It can also relate to the attitude toward education. It can also be some cultural issue or inadequate funding. Also, sometimes inefficient early education. And now when it comes to the experience with interface agents, so we're still focusing on adults. So as human being, we've got different personalities. The same also with adults. They have distinct personality that differentiate them from one another. So we don't always act as the same way. So because of that difference in terms of human being, so of course the interaction with agent also may be affected in different ways. So it's going mainly to depend on adult personality, emotional state, and how they might respond to various kind of interface. Because as you know, interface, we use different types of characters, as I say earlier on. So the significant, now when it comes to this interface agent research, most of the research which have been done earlier on, they concentrate more on younger individuals in educational settings and broader demographic. So there's few research which have been basically focused on how there are few research which have investigated how adult population with limited exposure to technology engage with agents. There are few of them. Although they are there, but there are few of them. That takes us to formulate this research question. To what extent are adults familiar with interface agents? So in terms of, we needed to collect data. So in terms of participants, we had 100 participants, which they differ in terms of age. They're also in terms of gender, both male and female. So in terms of data collection, we use mainly questionnaires. The aim of using questionnaires was basically to assess participant familiarity level. That familiarity level was assessed in two ways. The first one is the degree of exposure, of course, with agent. Also, we check the belief about the interface agent. So in terms of analysis, we use basically descriptive statistics to analyze our data. So the first question was basically about the mobile phone ownership. So as we know these days of technology, everyone, of course, has a mobile phone. So that was the question. We asked them, do you currently own or use a mobile phone? So out of 100 participants, all of them accepted that they currently use a mobile phone. So in terms of the interactions with interface agents, so we also ask them, since they have their own mobile phone, so we ask them, do you play games on your mobile phone? So 92 out of 100, they say it was yes. So 8 was basically no. Okay, so we also wanted to check the perception and the perception toward basically interface agent. So That was the question. We basically had two questions here. How do you feel when interface agent like animal robots play a role of human in the game or movies? So some of them, as you can see, 56 of them, or 56% was optimist, 35% were neutral, and then 9% was basically negative toward that feeling. Okay, so we also ask them if they accept that. Do you accept as true? So that interface agent in a game or film are capable of performing the task or action that they are designed to perform. So 85% of them say yes, of course. So 84% of the respondents say yes, and then 16% say no. Okay, so in terms of findings, so these are basically the general findings for these studies. So the findings have shown that all participants, they confirm basically that they own a cell phone device. So nearly all participants, they confirm that they have engaged in a gaming on their mobile phone. So basically they've played already a game using their mobile phone. So the participants also expressed mixed opinion when we're asked about the different role assumed by interface agent in game and animated movies. Okay, we also find that there was a significant number of participants who believe that the interface agent could execute the task assigned to them or perform action assigned to them in games or movies. But still, there were some small portion which had doubt about those agents performing those specific characters. Okay, so in conclusion, so it can be concluded that, so we've seen that adults have some level of familiarity with interface agents. Based on the data which we analyze, we see that they've got some level of familiarity with interface agents. Because they have that level of familiarity with interface agents, so I say earlier on at the beginning, the interface agent basically have been incorporated in most of, the area in our everyday life. So because they are familiar, they have some level of familiarity with this agent. So we need a support system, right? We need a support system. A support system should be implemented to educate adults more about interface agents, especially those who are not confident of doing so. So we've seen that there were mixed reaction about that. So to do that, of course, why do we have to do that? It's important because interface agents are becoming part of our daily life because we interact with them in almost all the area when performing our daily routine. So let's say shopping, also using some government services and all those other things. So that's basically the end of my presentation. Any question? So if you have any question, please, you are welcome to pose them.
Fine. Just one question, Nitima. Is my voice audible?
Yeah, it is.
Fine. So you already explored or related to a mobile phone usage and so on. Fine. You can explore the other areas as well as you need to consider the larger database for finding the reasons.
Sorry, I did not hear you. You are breaking. If you can repeat your question, please.
Right now, you have just given the information related to the usage of mobile phones for an adult, right?
Yeah.
You can explore some other areas also or considering few more different types of questions, and that too by considering a larger database pool.
Okay, now I'll consider that in, when I improve the paper, basically to publish a journal, I'll consider. Thank you very much.
Thank you so much. So we'll be moving on to the next presentation. Next, we have Samar to present his paper title, Autonomous Disaster Planning Relief Agent. Are you there?
Hi, I'm Siddharth. I'll be presenting on behalf of Samarth. I'm one of the co-authors.
Fine, no issue. Just a small request, if possible, try to skip the introductory part so then we can cover the main focus of paper in a limited time.
Okay, sure. Yeah, so my screen is visible, right?
Yes, it is.
Okay. So I'll skip the introduction. So our project is Autonomous Disaster Planning Relief Agent. So it is
Samar,
an
you need to
agent
go
which
for
is
the slideshow view. It is the last slide it is showing right now. Thank you, slide.
Yeah, we can see it now.
is the introduction. Yeah. Yeah, so I'll move on to the architecture part of this project. So this project consists of an NLP-based disaster analysis module. So it uses a fine-tuned BERT model and scrapes data from Twitter, which after scraping it classifies it into disaster-related categories. So suppose there's a there's a disaster related to tsunami, so it will classify text and put it into tsunami and then output tsunami. Okay, so this is a disaster related to tsunami. So that's how it identifies. And after that, priority scoring mechanism, which it includes the number of tweets generated about the related disaster and then prioritizes the and gives it a score over this. And also it extracts locations using named entity recognition, so which then later is converted into coordinates, which will be used later for our confirmation agent, which uses near real-time satellite imagery, and it can then detect and confirm, okay, so there has been a disaster occurred here, so it uses the image also for analysis. And yeah, so after once this is done, so route optimization is also being done using the open route service API. So the minimum time it will take for relief centers to come over there is how it will optimize this and place it over there. And finally, dynamic decision making also. So if any road closures, vehicle capacity, or severity are all considered during the dispatch, which will be included. So here you can see, so in a nutshell, first data will be collected and then analyzed using BERT models. And after that, confirmation will be done using the image data from Google's Earth Engine. And once that is done and it is confirmed that it is a disaster which has occurred, so response coordination will be done in which a model can predict how many ambulances or how much of help would be required there. And once that is done, automatically the route will be optimized and the fastest way to reach there will be provided to the relief centers. So here is the result and performances. So this is being compared to a traditional system keyword based improvement model. So 0.89 was the precision for classification of our model, and recall was 85, F1 score was 87, and the location accuracy was 82. So, and this file compared to traditional models, which are generally 62 and recall might be 78. So this is a slight increase, which will help us reduce latency and accuracy also while providing the solution for this. And the satellite-based damage classification models also strongly can, classify how much damage is being actually done right here. So no damage scores and minor damage scores. So these are the confidence scores generated by our model for a specific images, and overall also is given 84 accuracy over here. Discussion. So the key strengths of the system are it is real-time, autonomous, and scalable. It can reduce dependency on manual coordination and which can resultingly enable faster responses. So the limitations over here are dependency on external APIs, and this is currently only for English data. So any other languages are not incorporated yet. And yeah, that's it for the architecture part. I had skipped the introduction and the
Fine, fine. Thank you. I
yeah.
think it's really a good idea. Just one question. Have you gone through the state of art for selecting a BERT method? Because there are
Sorry,
a
sir,
lot
could
of
you
few,
repeat?
there are a lot of few other algorithms also available. So you need to take care of choosing that particular one, which can be appropriate for your, probably the data part.
Sure, sir, I'll look into it.
Fine, thank you.
Yeah, thanks.
Thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have Jasmeet Kaur to present the paper title Comparative Evaluation of Deep Learning Models and Ensemble Classifiers for Early Detection of Parkinson's Disease. Are you there?
Yes, I'm there.
Yeah,
I
you
will
may
be
please
sharing
start
my.
with the presentation. Are you sharing? Yeah.
Is my screen visible?
Yes,
Is my
it is.
screen?
Yeah, it is visible.
Um. Okay. Just a second. Good afternoon, everyone, the chair members, the panel members, and the audience. Here I am Jasmeet Kaur from SGS ITS Indore, presenting the paper title Comparative Evaluation of Deep Learning Models, an Ensemble Classifier for the Early Detection of Parkinson's Disease. Basically, my goal revolves around presenting different models and their clinical reliability so that we can see if they are collaborated and present interpretable AI models for detection of the clinical data, whether it is detecting the Parkinson's early or not. So basically, Parkinson disease, if we talk about, revolves around a trap kind of symptoms in which we have a heterogeneous systems, and these heterogeneous symptoms, basically sometimes cannot be properly found out from the clinical data. And if we are having a remote monitoring caregiver system, so sometimes the updation of these symptoms may take time, and due to which there is a gap between the symptoms which are detected. So basically, my approach works on these different AI models, which we basically are using for the early Parkinson disease disease detection. To find out the motor and motor features that effectively cannot be captured by the traditional systems, or we can say that whatever the clinical systems are there, they are subjective. So early stage detection is the hardest, but it is the most important, which we are required to do for detection of this Parkinson disease. So basically, we are working on these 5 models to have a complete methodology on the working of the clinical data systems in order to find out if the Parkinson features are identified by these particular AI models properly on that clinical data or not. So the approach works with a normal CSV Kaggle dataset, which is available freely, and the complementary models which were evaluated are BLSTM booster, attention DNN, CNSTM, autoencoder booster, and stack ensemble. And the pipeline which is followed is similar through all the models, and then evaluation is done on different parameters. Talking about the literature survey. So literature survey works on worked with different data sets like voice, image, then through the video capturing. But Here I have taken the simple CSV dataset because the clinical structure of the data which is available, it is normally the similar kind of the data which I took. So first I thought of working on this so that I have a on these normal data, and the framework moves with the data set, the pre-processing, splitting, and working on this model which had different labels, and according to the labels the model evaluation was done. And after this, the model which obtained with a higher percentage of accuracy was stack ensemble, in which basically I chose heterogeneous models, and each models captured different decision parameters and patterns, and the meta learner that fuses only to the collaborated probabilities, and thereby which the overfitting was reduced, and this gave the best accuracy out of all the models, because as it worked on the CSV dataset, so that dataset was small, simpler, tabular. Due to this, the other models, as they were deficient of the large data, so they were not able to produce much accuracy which Stack Ensemble produced. The dataset which I worked was having 2105 records with 35 attributes, and these attributes were basically the heterogeneous combination of symptoms which we receive from the PD, that is Parkinson's disease. And motor symptoms were the tremor and this, and non-motors which generally show up before, and motor symptoms generally show up later. So there was a combination of heterogeneous data set, and the model architecture was basically the combination of these five models, that is VLSTM, Booster, Attention DNN, CNSTM, Autoencoder Booster, and Stack Ensemble. So basically, I took these five models to have a methodological completeness so that I can work with the basic models also, and for the deep models to check if clinical data representation in the form of CSV can have a better accuracy or not. So comparing the performance, the best was through Stack Ensemble, giving an accuracy of 93.82, and moving then on to CNSM, which was the deep model, which performed better after Stack Ensemble, followed by the other models. This is the comparative model comparison, giving the working on with different factors, that is accuracy, precision, recall, F1 score, then ROC, AUC, PR, AUC, MCC, kappa, and barrier. So these were the different parameters on which I tracked down my different models. So obtaining highest accuracy by Stack Ensemble, which achieved the highest accuracy. After this, a sharp interpretation was done basically in order to find the features which contributed more into the uh, finding of the PD symptoms. So basically, the features were like the motor services, then the cognitive decline, which was a non-motor, then functional assessment, and tremor. These four features, which were basically from F23 to 26, contributed more into this PD working. So this SHAP analysis helps to give a direction towards the usage of these models in the by the clinical persons. And the one more analysis which was at the end of this was that non-motor features as they appeared earlier, so they contributed very large factors into the motor symptoms also, which are a part of heterogeneous symptoms which PD, that is Parkinson disease, generally have. And then this is the overall ROC curve for the different models, and here Stack Ensemble achieved the most of the accuracy. So moving on to the conclusion, so basically on the clinical data set, if we talk about, which is similar to the data set I took, so ensemble models had a better superior working than the other models, and also the sharp interpretation helped to give it a direction to the clinical support of the data. So my future working include that this data to be extended to the real-time data, which will basically from the sensors, and working on the longitudinal prediction so that continuously data monitoring can done, which can help in the remote monitoring of patients by their caregivers. Thank you, and I'm ready for the questions.
Thank you so
I
much for your
think
presentation.
you have done the comparison of all models based on Parkinson, right?
Yes, sir. That was basically because I wanted to
That's
move
fine,
on.
fine. So at least we can get an idea at which particular point which model is better.
Yes, sir.
Just small suggestion, you can go for the larger pool of database because right now you're considered around 2000 records only.
Yes, sir.
So for
Sir,
accuracy, you might get some different result compared to what you have achieved.
yes, sir. Yes, sir.
And you already suggested rightly that you can go for even real-time data also. Fine.
Yes, sir. Yes,
Thank
sir.
you. Thank you.
Thank you. Thank you so much.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Sohail Ahmed to present the paper titled Design and Evaluation of IIDS, a two-phase intelligent intrusion detection system. Sohail, are you there?
Yes, I hope I am audible as well.
Yeah, you're audible as well. You may please begin. Yeah, your
Honorable
screen is visible.
Professor Bimal Patel and my dear participants, as introduced by Anshika Jain, our paper is having the title Design and Evaluation of IIDS. Basically, it's a two-phase intelligent intrusion detection system. Myself, Sohail Ahmed, along with my co-authors Amano Yubani and Madiha Nazir. So these are the contents that I'm going to discuss over the next 10 to 15 minutes. So starting with just an overview of the introduction, that the cybersecurity nowadays, it's not an optional thing. With the rising cybersecurity threats, it's quite imperative to safeguard our networks. As we know that AI is playing a two-edged sword role in case of cybersecurity. On one side, it is securing our networks, and on the other side, the same AI is being used to break the shackles. So our approach in this paper is we're introducing an intelligent intrusion detection system that combines real-time traffic monitoring with machine learning-based traffic classification. The major goal of our work was to build a reliable and adaptive mechanism that strengthens the security of enterprise networks in the modern range of cyber threats which we're facing nowadays. So, the motivation behind this work, as we all know, over the last 5 to 10 years, there has been a continuous surge in the cyber attacks, and I'm quoting some dailies which are reporting various types of attacks which have been encountered. First, I'm quoting here DDoS attack strike the Indian airports. Likewise, there was a malware attack in 2022. There was a 31% surge in the malware attacks in 2022. And you can see here, I'm quoting that 53% of Indian organizations fell victim to spear phishing. And apart from that, you might have seen this year as well that during the Operation Sindoor, we as a nation faced around 15 lakh cyber attacks during that operation. So our focus was to have a sort of intrusion detection for our enterprise networks wherein we can block such attacks. So this is the related work which is to some extent related to our work. Starting with the first, that is ISA. They have provided an IDS using the various data sets to train and test. And but the problem, as I'm quoting here, is and it's having high positive false positive anomaly detection. The second approach, which is to some extent related to our work, is Liu et al.'s work. They are using the data set of KDD. They are using the isolation forest that isolates outliers efficiently with linear time complexity, but they cannot classify different attacks. Then the next work is of Dahir, and you can see here they are using the CCIDS, which we have also used the same data set. There is high detection accuracy, but they have focused on a single attack, that is a DDoS attack. One more paper I'm quoting here, that is of our own university, Sajid. They have worked on the cloud IDS, wherein they have used the neural networks and XGBoost. But the methodology they have used, it requires quite significant training data and resources. And the last paper which I'm quoting here is they have used an unbalanced IDS dataset. They have used various machine learning models for raw unbalanced IDS in multi-class classification. There's a limitation is class imbalance and insufficient data for real attack types. Now, this is the workflow which we have used, which we have followed in our project. Step one, we capture the network traffic. Then from that real-time traffic, we extract the features, do some pre-processing. Then we pass on that information to the detection engine. So the main core of our project is detection engine, where we use the ML models to detect whether there is an attack or not. Then we store the output into the database, And from that database, we use the APIs to fetch the information and display that on the dashboard. Now, this is the detection engine. That is the core of our project. We are having two-phase detection of these attacks. In phase one, we are using the isolation forest, and in phase two, we are using an ensemble of three different classifiers: XGBoost, logistic regression, and random forest. And output predictions, as I said, we are putting that on the dashboard. Now, why this dataset CSE-CI IDS 2018 originated from the collaboration between CSE and Canadian Institute for Cybersecurity. They have simulated the realistic enterprise network, having 50 attackers, which attack the 450 entities. Out of those 450, there are 420 workstations and 30 servers. It incorporates 7 distinct attack scenarios, which I'm coding here are brute force, heartbleed, botnet, DOS, DDoS, web attacks, and internal infiltration. And not only these attacks, they have captured system logs, rich content, and every flow is being labeled in this dataset. And that is why we have used this dataset. And this is the future scope, and these are the characteristics of the dataset: traffic structure and sizes, their flow duration, protocols, packet lengths, and there's a temporal behavior as well. Interarrival times is there, active or idle periods are reflected there. And apart from that, there are control and statistical indicators like TCP flags, which include acknowledgement, finish, push, down up ratio of the flows, and the packet length variance. Now, this is the distribution of attack labels in the data set. As you can see, majority of the flows are benign. That means they are normal traffic flows. And out of the entire data, the majority of the attack flows are DDoS, followed by DOS, then the brute force, botnet, and infiltration attacks. This is the distribution of attack labels in the data set. Then we go for feature selection, wherein we start with the data cleaning. We remove the irrelevant identifiers, the missing values, and we standardize the features for consistency. Then redundancy reduction, we eliminated the duplicates, highly correlated attributes to avoid bias. Then we go for ranking. And finally, as an outcome, we get a compact and optimized feature set that improves efficiency, reduce noise, and strengthens detection accuracy. Now, this is how we acquire the data and the extraction of data. We capture, as I said, we have captured the live traffic and convert that live traffic into structured flow records. Basically, we capture the live traffic using the Go library of the Go language. We sniff the traffic from the network interface. Then we normalize that data for the ML models, which we have implemented in Onyx or NX. Then flow timeout handling, we have handled the inactive flows. We set the expiration as 60 seconds. And finally, as an output, we get the normalized feature vector representing the statistical and temporal behavior of all the network flows. Now, as I said, the detection engine, we have used two-phase detection engine. We have trained the ML models to detect anomalies, and after the detection of anomalies, we classify the traffic into various categories. As I said, we have used ONNX models to execute these ML models and integrated that with the Go-based interface engine. In the workflow, we are first detecting the anomaly. As an isolation forest, we are using to detect the anomaly. And once we detect the anomaly, and that's a traffic pattern that is having anomalous behavior, we later on classify that anomalous traffic flow into different categories using different classification, ensemble of classification algorithms like XGBoost, logistic regression, and random forest. And the output, as we can get the normal or the anomalous traffic in the first phase, and the second phase categorizes these anomalous traffic flows into various categories, which I'm highlighting here is DOS, DDoS, brute force, and web exploit. So these are the results of the phase one. wherein we are using the isolation forest. As you can see here, the anomaly detection stage achieved an overall accuracy of 70.8%. The main focus here is that we should not leave any attack flow. The precision of the phase one was quite low, that is 64.7%. That means some more normal traffic flows are being classified as attack, but this thing was tackled in the second phase, wherein that normal flow is being left as such, and the attack flows are being categorized into different categories. So this is the precision comparison of phase second, wherein we are using the three classifiers: RF, random forest, XGBoost, and the logistic regression. As you can see from this diagram, that the XGBoost provide the most.
Sorry to interrupt you, but you have 1 minute to conclude your presentation.
Yes, I'm about to complete. So random forest was providing us better. The best was XGBoost, followed by the random forest. But as you can see here, the logistic regression performed poorly on minority classes, confirming that linear models are not robust for complex traffic patterns. So this is the conclusion of our work. As I said, it's a two-phase intelligent intrusion injection, where in phase one we used the isolation forest, having a good recall of 91.6%. In the second phase, we used the three different algorithms, three different machine learning models: random forest, XGBoost, and alert, to classify different category of attacks, which includes DDoS, botnet, and brute force. And the main contribution of this work was the real-time Go-based implementation along with the Onyx. And in future, we will try to work on the class imbalance mitigation through data augmentation, smart-based oversampling, or cost-sensitive learning can be explored to further enhance the detection of infrequent and stealth attack times. So that is all from my side. If you have questions, you can ask.
Fine. So at least what I can learn something like it's a hybrid approach.
Yes, sir. It's a hybrid approach.
So the phase one result you are trying to feed in phase two by using the three approach. Am I right?
In the first phase, we are using the isolation forest. In the
And
second
that
phase,
result you are trying to feed in second.
yes, sir. Yes.
So in phase one, you are getting 91% something like accuracy. And after feeding a result by combining the hybrid one, you are getting somewhat less.
Yes, sir. In the phase one, we are getting the recall of 91 point something percent, and in the phase two,
Fine. Just one suggestion. What you can do, you already mentioned the literature survey where you are trying to show the limitation of other work.
yes, sir.
Right? So if possible, as a future part or maybe in terms of journal you want to proceed on, you can compare the result with the state of art.
Fine, sir. Fine, sir.
Fine? Okay, thank you.
Thank you, sir.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Bright to present the paper titled Enhancing Federated Learning Performance Under Poor Network Conditions Through a Modified UDP Protocol in the NS3. Are you there?
I am here. Let me just share my screen.
Yeah, you may please share your screen. Yeah.
All right, can you see my screen?
Yeah, I can. You may please start.
All right, so I'll be presenting enhancing federated learning performance under poor network conditions using a modified UDP in NS3. Just a basic overall outline of what I'll be talking through. So we're just gonna go over these points. So before we come into the nice stuff,
I think you can skip the basic part. If possible.
Okay.
You can
All
shift
right,
to
that's
your
fine.
work as well as the result part.
Absolutely. All right. So essentially, the motivation of the work came from trying to preserve data, and we have at the moment two big providers of federated learning simulations, including PyTorch and TensorFlow. With these two, they mainly focus on the results of the global model, and then they don't put a lot of emphasis or a lot of effort into allowing researchers to essentially experiment with the networking side of things. Ideally, when you are federating or you are simulating federated learning global models in different scenarios, you would want to cater for packet loss and poor network conditions. And that's kind of what led to us developing the modified UDP that you see over here. So with the modified UDP, the idea, and this is kind of presented in another paper, so I've added a link to this if you want to do a little bit more reading. I'll just give you a high level view of what this actually does. So essentially, what this does is it allows us to add introduce reliability to the traditional UDP while maintaining the lightweight nature of UDP. So what this means is when the client sends packets to the server, which are machine learning parameters to avoid containing user data, these packets are then transmitted in different sequences, which we've introduced. And once these are transmitted to the server then does an aggregation and responds back to the client. If the network conditions are poor and the packets are missed, the server is then capable of sending responses back to the client to try and get these missing packets, meaning that missing packets are sort of retrieved on demand, and there is no kind of communication overhead or any connections that need to be made up, similar to what TCP essentially does. Now, because we kind of don't have a simulation environment, or at the moment, the two big simulation platforms that we get do not allow us to add networking components or kind of play around with how the networking side of things. We had to develop our own simulating environment, and this simulation was developed using the NS3 network simulator. So within the NS3 simulator, we integrated it with the modified UDP and the traditional UDP. This uses the NS3 error rate to simulate packet loss. So essentially, you see a bit later on when we try to send packets across, it will sort of simulate what would happen in the real world when the actual network link is not transmitting properly and there's sort of packet loss and poor network conditions, and how those are essentially affected. This module can scale up to an amount of nodes, and being the total number that your computational resources can handle or accommodate. In our research, we kept it to 11, where we had 1 server and 10 client nodes due to computational limitations, but this can be increased. Moving on to the next, in the experimental design, we kind of did the comparison, a basic comparison of the global model, which is the model that is produced at the end of the simulation, of the performance of the modified UDP against the traditional UDP. So one that has the recovery mechanism while maintaining lightweight, and one that does not have the recovery mechanism. We kept it simple and tracked the commonly tracked metrics in federated learning and most machine learning scenarios: your accuracy, your loss, your F1 score, your precision, and your recall, just the basics. And within the simulation, we simulated in 3 different conditions. We have an error level of 0, which is 0%, so no error, perfect network. These are the ideal conditions. We have 0.05, which is 5%, and this is where the network starts getting a bit bad. And then 10% is what we kept as our highest network error rate to simulate packet loss. To evaluate the model, we essentially use the Cipher-10 dataset. So this dataset was chosen because it's kind of widely used across a lot of federated learning scenarios. So there's an MNIST. The Cipher-10 dataset set consists of 10 classes, and these 10 classes have 50,000 training images and 10,000 test cases. Within this, we managed to get 3 different results. So in the 3 graphs, you see that the blue represents the traditional UDP, the red or orangish color represents the modified UDP. So when we ran them across ideal conditions as expected, the models perform the same way. There is no packet loss, there is no errors, so everything sort of went smoothly. Once we started introducing errors and packet loss as 0.05 in the middle image that you see over there, you start seeing that the modified UDP managed to maintain accuracy, managed to kind of grow in a steady fashion, which is expected. However, the traditional UDP started spiraling and sort of going up, losing accuracy, and not maintaining its performance, and that is due to packet loss. And then in the last image, you see at 10%, you can see that modified UDP having a bit of a dip in accuracy, but maintaining its overall performance, while the traditional UDP could not recover and could not get to the same levels. Now, the reason why in the 10% simulation, why we see that the modified UDP has a bit of a spike, again, comes down to networking. So essentially, with a poor link or poor network conditions, when the server responds back to the client trying to get a certain packet, we introduced a retry mechanism similar to what TCP has. So it would try 3 times, and if it cannot reach the client, then it sort of lets that particular packet go. And with this, we were able to maintain the accuracy. We're able to get most packets sent across, whereas the UDP would essentially just lose the packets if the network conditions are bad. And with this, we were able to avoid or kind of work around the issue of data skewness due to missing parameters, because we're dealing with different nodes, different devices that could collect different images. So if we go back to our previous data sets, one device could essentially have images on horses, while the other one has images on planes. And if the horses one fails and the planes class is sent, that kind of causes data skewness in a bit in our model, which means the performances or final performances will essentially not favor horses. So that's kind of what you are seeing over there with the traditional UDP not being able to actually get up to speed with the performances. So within this research, we developed the modified UDP. We developed the NS3 environment to accommodate this modified UDP. There is another paper that was published as well that talks about how we've modified this. We've extended the modified UDP to add a greedy approach that actually deals with the packet loss or the skewness that you're seeing with the graph over there, where in the 0.10 or 0.1, it sort of dips down over here. So that's out there if you want to do some further reading. Future work, we've identified quite a few areas of research that could help in extending this. And I won't name all of them, but I'll kind of name just those that I think would be very good in the short term, which is exploring higher packet loss rates in the networking conditions, simulating more challenging networks. Because we had computational limitations, we weren't able to simulate as many nodes as we'd like to, or go to as many rounds as we would have essentially loved to, or even add higher packet loss rates as we'd have loved to, because that introduces complexity in the network. Extending simulations with the increased number of rounds, which I kind of touched on a little bit just now, and scalability, which is adding more nodes. And with that, if anyone is free to collaborate or want to kind of participate in the research with ideas, feel free to just reach me on my email address. Yep, open for questions if there are any or suggestions.
Fine. So I think you've done the part or the simulation on NS3.
Yes.
Fine. So you can even continue, as you rightly said, you need to go for a scalability part just by increasing the network size or maybe increasing the number of nodes. Then only you'll be able to find out the much better result compared to what you've done.
Essentially, that is the idea. So it's to try to get a little more computational resources so we can get to those levels.
Exactly.
So that's sort of the base of the work.
Fine. No more question from my side.
Thank you so
All
much
right,
for the
that's it.
presentation. We'll be
Thank
moving
you.
on to the next presentation now. Next, we have Nikita to present the paper titled Generative AI-based Framework for Vulnerability Detection and Cybersecurity Tutoring. Nikita, are you there?
Yes, I'm there. Can you hear me?
Yeah, I can hear you. You may please start with your presentation.
Sure. I'll just share my screen. Oh, is my screen visible?
Yes, it is.
Sure. So the topic that I'm going to present today on the behalf of my team is a generative AI-based framework for vulnerability detection and cybersecurity tutoring. So firstly, I'd like to address the cybersecurity skills gap which exists currently, which is basically the statistics say that global cybercrime losses are expected to top $10 trillion by next year, highlighting the scale of the challenge. And small and medium sized businesses are disproportionately affected by sophisticated cyber attacks due to limited resources. Also, the main problem that exists today, in simple terms, is that traditional vulnerability scanners produce dense, verbose technical reports, which overwhelm non specialist administrators and thereby hinders effective response. So, in order to tackle this problem, me and my team have come up with a framework, which I'll be talking about. So the framework essentially does integrate a pipeline, and the pipeline consists of automated scanning, explainable AI tutoring, and sandbox remediation. So, talking about the automated scanning part, the automated scanning leverages multiple vulnerability detection tools, which comprises of Nmap, Nessus, OpenVAS, and Zaproxy, which has the main aim of identification of vulnerabilities efficiently and comprehensively. We move further to explainable AI tutoring, which leverages Google Gemini to transform complex technical reports into natural language explanations so that they can be understood effectively by people who are newcomers to cybersecurity or who do not have that much technical knowledge for that matter. Thirdly, we have sandbox remediation, which is one of the main, most important parts of our framework, which basically provides a safe environment using Claude in Docker containers for users to practice and validate remediation steps without the risk of risking live systems. And the design science research approach that we've catered for includes the problem definition, which included identification of escalating cybercrime, the small to medium sized businesses' vulnerabilities, and the global critical shortage of cybersecurity professionals. Next, we came up with formulating the goal, which included the objectives such as improving vulnerability detection, clarifying the verbose technical reports, and thereby enabling safe remediation practice for non-experts. We then came up with solution designing, which included the framework that I just talked about, which was an integrated system comprising of automated scanning, AI-powered tutoring, and Docker-based sandbox remediation environments. The fourth step was to evaluate our project, and we did that on 20 volunteers, which included junior admins, grad students, and SMB IT personnel. So we evaluated our project based on multiple parameters, which included detection accuracy, explainable clarity, remediation reliability, as well as usability. The impact of our project was much more than we had considered. So it led to an overall improvement of 35% in vulnerability comprehension, 80% plus remediation success rate, 85% task completion rate, 87% severity rating accuracy, 92% reproducibility, and 98% rollback success rate. So this was the statistics, what the statistics showed. We have represented it in the form of a graph, which basically shows that before we actually used our framework, the high vulnerabilities, the most important vulnerabilities, were least taken care of. And we've made sure that in our project, which is the navy blue colored, the light blue colored, that talks about how it has tackled the high vulnerabilities, which basically means most critical vulnerabilities, which can cause the most harm to a system. Similarly, we've catered for medium as well as low vulnerabilities. And now, why this framework actually matters? So, this framework matters because it is accessible and simplified. We've made sure that we've made a project that is actually accessible by SMBs because that's what our target audience is. Secondly, practical skills and confidence. This using this framework will not only give confidence to the people who are using it, but also give them practical skills which they can leverage in other fields of cybersecurity as well. Thirdly, there's consistent and reliable results, which we've just discussed. Now, the built-in safety mechanisms that we've catered for includes container isolation, which is the Docker-based container for sandbox remediation. Then we have command filtering integrated, as well as schema-based control and rollback success. Just in case there is something wrong happens, then rollback success is pretty much taken care of. Next up, we have transforming the cybersecurity practice. So we've made sure that we have enhanced remediation. That is, we have the remediation success rate has soared up to 85% with the framework and a dramatic increase from just 44% without tutoring. Secondly, improved comprehension. Vulnerability comprehension for non specialists improved by a notable 35%, demystifying complex security reports. Thirdly, reduced errors. We made sure that the initial procedural mistakes averaged 6.2 per task, with retry rates consistently decreasing as the user skills developed. Lastly, but not the least, scaling security expertise. The framework enables non experts to confidently perform scanning, tutoring, as well as remediation, facilitating security implementation at scale. Now, the future directions that we look forward to and we want to incorporate in our project is that we want to make sure that our project is used in real world field deployments, because that is when we will be able to know the impact of our project at a larger scale. Secondly, adaptive personalization. And thirdly, investigate the local deployment options for LLMs to maintain data confidentiality. So, one question that may arise is that why would someone want to share the vulnerabilities of their system? That is the reason we want to look at this aspect in the future, which talks about investigating the local deployment options for the LLMs to maintain the data confidentiality, as well as democratizing cybersecurity for all. So, one of the major objectives that we've taken care of is that we've democratized cybersecurity, because we knew that SMBs do not have access to large scale infrastructure that they can incorporate because of the cost aspect. And that is the reason we've made our project, that is the framework which caters to SMBs as well. Yeah, so that should be all from our side. Thank you for listening till here.
Fine, just one question. In your second stage, probably you've gone with Gemini. Am I right?
Yes.
So right now, probably there are a lot of LLM available. In fact, in case of Perplexity also, we have got the option that whatever prompt or query that we are giving, the best probably LM will get chosen and accordingly you'll get the answer. So there might be a case you might get some good result if you're trying to use different LLM and then trying to compare the answer rather than only focusing on Gemini.
True, sir. Yes.
Right? Because we have got the Perplexity, we have got the ChatGPT, different versions available, right?
Yes.
So
Yes.
the best one probably you can choose that might have effect much better in case of last final accuracy also.
Yes, sir.
Fine? Okay, thank you.
Thank you
Thank
so
you.
much for your presentation. We will be moving on to the next presentation. Next, we have Megha Gupta to present the paper titled Machine Learning Based Detection of Tea Leaf Diseases of Assam, India. Are you there, Megha?
Yes, ma'am.
Yeah, you may please begin with the presentation.
Yes, ma'am. My
Yeah,
presentation is visible, ma'am.
yeah, you may start now.
Okay. Good afternoon, teachers. Myself, Megha Gupta, and my paper ID is 1300. My, my title of the paper is Machine Learning Based Detection of Tea Leaf Diseases of Assam, India. This is the workflow of my study, which includes 5 steps. First step is the image acquisition. In this, a tea leaf dataset is prepared, which includes 6 classes, healthy class and 5 disease class. Step 2 is the image acquisition. In image pre-processing, in this step, various pre-processing techniques are applied on the tea leaf dataset. Step 3 is the image segmentation. In this, the main object is separated from the background object. It includes 2 steps. In the first step, 2 segmentation methods are applied on the tea leaf dataset so as to obtain the binary mask. Further, this mask is cleaned using morphological cleaning and largest contour filter to obtain the refined mask. In the step 2, leaf-only pixels are obtained. Step 4 is the feature extraction. Total tailor features, including 6 texture, 3 color, and 3 shape features, are extracted from the leaf-only pixel. The output of the feature extraction is the feature matrix. Step 5 is the image classification. In this step, 6 machine learning models, including decision tree, random forest, extra tree, gradient boosting, extreme gradient boosting, and k nearest neighbor models, are applied on the tea leaf dataset, and their performance is evaluated using the evaluation matrix. Now I will explain each step in detail. First step is the image acquisition. In this, the researcher visited these 7 tea gardens of Assam that belongs to different districts to collect the images of healthy leaf, blister blight, brown blight, leaf red rust, red spider mite, and tea mosquito bug. Using 3 devices, these images are captured. The output of the image acquisition is the tea leaf dataset is prepared, which includes 6 classes. Each class is having 1500 raw images. Total raw images in the tea leaf dataset is 9000. This tea leaf dataset is validated by 3 persons. First is by the trained agriculture staff, second by the researcher, and third by Professor Piyush Pandey from the Department of Microbiology, Assam University, Silchar, Assam. Step 2 is the image pre-processing. In this step, various pre-processing techniques, including resize, zoom, flip, rotation, shift, shear, and median filter are applied on the T-leaf dataset so as to prepare the dataset for further processing. The output of the image pre-processing is the T-leaf dataset, which already has 6 classes. Now each class has augmented images 13,500. Total images in the T-leaf dataset is 81,000. This dataset is available on the Mendeley data. Step 3 is the image segmentation. In this, the main object is separated from the background object. This includes two steps. In the first step, I have applied two segmentation methods. First is the lab OTSU segmentation method. In this, the image is first converted to the lab to obtain the leaf color pixels, and further OTSU finds the best threshold to separate the leaf from the background. This method outputs the raw binary mask. The second method I have used is HSV plus EXG segmentation method. The image is first converted to the HSV color space and identify the leaf color pixels. This provides the HSV mask. EXG find out the excess green leaf pixels and identify the threshold to separate the leaf from the background. This method also outputs the binary mask. After obtaining the binary mask, one segmentation method is chosen that provides the best mask. After that, this mask is cleaned using morphological cleaning and largest contour selection to obtain the refined mask. In the second step, leaf only pixels are obtained by applying the refined mask to the original image for the feature extraction step. Step 4 is the feature extraction. In this step, various features are extracted from the leaf only pixels. First is GLCM method is used to extract the texture features. Texture means to identify the leaf surface patterns such as the roughness, smoothness, spots, etc., and converting this into numbers for the machine learning models. Second is mean HSV color features are used to extract the overall color of the leaf, and these are also converted into numbers for machine learning models. Third is shape features are extracted from the leaf on the pixels, and these are also converted into numbers for the machine learning models. The output of the feature extraction is the feature matrix in which each row is an image and each column is a numeric feature. Step 5 is the image classification. In this step, I have applied 6 machine learning models on the T-leaf dataset, and their performance is evaluated by calculating the accuracies. First is the decision tree. Decision tree has only one tree, so its accuracy is almost is so its accuracy is predicted wrong mostly. It provides less accuracy and has overfitting problem. It uses best feature and best threshold to separate the data into branches. The process continues until the leaf node is pure. The second model is the random forest. In this model, there are many decision trees. Each decision tree is having random data and random feature. This model choose the best threshold and best feature to split the data. Based on the majority voting, the class is predicted for the new image. This model provides high accuracy and has less overfitting problem than the decision tree. Next is the extra trees, which has many decision trees than the random forest. So its accuracy is more than the random forest. It uses it uses random threshold and best feature to split the data, and based on majority voting, the class is predicted for the new image. The next machine learning model I have used is K nearest neighbor. It uses equivalent distance to find out the distance between the new image and the other samples in the training dataset. After that, it finds the value of k, and based on the majority voting, it calculates the predicted class. Next is the gradient boosting. It starts with the weak model whose prediction is almost wrong. The model then find out the errors, and after that a new tree is formed which overcomes the problem of the previous tree. The new tree provides the correction value, not the class label. The new prediction is the sum of the old prediction and the class and the values. After that, the model again find out the errors. The process continues until a model is formed which is error free. The last model I have used is extreme gradient boosting, which is an extension of gradient boosting. It is a powerful and a popular model than the gradient boosting because it uses some extra features such as second order gradient and regularization. So it provides more accuracy than the gradient boosting. Next is the extreme gradient boosting model feature importance. In this, mean Hui and mean value, these two features contributing the most to attain 97% accuracy for the XGBoost model. These are the references that I have included in my paper. So this is my work.
Thank you so much for your presentation. So, do you have any questions?
Fine. So I think probably is my voice audible?
Yeah, you are
Yes, sir.
audible.
Yes, yes.
So you just done a comparison based on machine learning classifier, right?
Yes, sir.
Start probably then considering you can suggest a framework by considering the XGBoost method, and then you can elaborate the part for some other use also.
Sir, your voice is not clear.
You can probably use the both the machine learning identifier,
Yes, sir.
and then probably you can even use the same part for some other use concept also, rather than considering only T.
Sir, I have used 6 machine learning models and
So that's
applied
fine,
on the
that's fine.
T-lift. Yes,
But
sir.
what I'm suggesting is even you can go for some other types of views also.
Yes, sir. Okay, sir.
By considering even a larger database, because right now probably your use is something like 1900 images only.
Yes, sir.
Right? So that is
Okay,
just a
sir.
suggestion.
Okay, sir.
Thank you so much for your
Thank you so much.
presentation. We'll be moving on to the next presentation. Next, we have Noor Jahan to present the paper title Simplifying Complex Concepts, AI Driven Video and Audio Tutoring System for Tomorrow's Engineers. Are you there? Noor, are you there?
Yes, I'm there. Hello,
Yeah.
everyone.
Hi, you may please
Can
start.
you can you see my screen?
Yeah, I can. You may please start.
Okay. Hello, everyone. My name is Nurjahan Asma. I'm a PG scholar from SRM Institute of Science and Technology, Tamil Nadu, India. My topic is simplifying complex concepts and AI-driven audio and video tutoring system for tomorrow's engineers. So the agenda for this presentation is like I'll be giving you an introduction. Then next will be the literature review. Then followed by the methodology, followed by result and discussion, and the last is the conclusion. So the introduction as my paper title. This is meant presently meant for this engineering students for the time being. It will be followed by all divisions and all parts of education systems in the future. So here there are always there is no app or there is no website which can be including all sort of text, quizzes, videos, audios, slide sharings, everything. So my idea is like watching this AI and listening to the lectures. It can help in many way understanding, but mingling all this together can make an easily formalize and even this can make a easy way to connect everyone's idea like adding visual like diagrams and workflows all together. And even when teachers or staffs or anyone is teaching, or even if we are listening to any video, we may miss some important points. But like giving the tone of these voices and quick speaking tips from the staffs can make us improve something better ideas in the future. So this is helpful and the main goal is to combine all the slides, spoken words, text, audios, videos, and into a key part of and finding the key part of the lecture and making it into a short summaries for quick revision at the latest or the fastest time being. Giving this, like I have added this question answer tool, which can give clear and step by step answers. This helps the system with real lectures and student feedback. The working will be spoken in the next few slides. And the main helpful uses of this is it is used for students or anyone who want to learn, make it very faster and clear up the confusions in a quick and fast manner. This shows the AI can improve recorded lectures and give the teachers or students or anyone the ideas to make the learning better. So next is the literature review. I have taken 15 to 20 different papers and the multimodal data sets like combining the videos, audio slides and narrating the supporting cross-modal learning and understanding it. And I have uses the RNN and CNN architectures to combine this reasoning to improve the quality of the question and answer accuracies. To enhance this, the learners enhance engagement and comprehensive through conceptual texting. I have used large language models, LLM, and I have made this survey based on 110 to 120 um, works and surveys from different persons, and a few of these key characteristics from the probabilistic reasoning in VQA, cognitive modeling frameworks, and video summarization techniques and audio fusion models. These are few of the literature reviews which I have included in my paper, and I'll directly go to the system architecture, which I can explain it in a better manner. So in this, from as usual, I have collected the data and made them into collected the data like raw data like videos, audios, images, or anything, and made them into an additional survey engine which captures this student feedbacks and to understand the learning effectiveness. I have added the feedback into this methodology. The load balancer here, which is used for enhancing the smooth performance by distributing multiple users requests effectively at the same time. It does not disturb other user requests, which can be made into a problem or loading timing. So especially when many students access the system at the same time, we don't have to wait and look into that. So I have also added this monitoring and logging system, which can continuously track system performance and help it detect errors or delays and ensures this reliability. And it also makes the response time a bit quicker. I have the main component for this is the AI tutoring code, the summarization technique or the module, the question and answer module, and the feedback module has been included in this. The summarization extracts the key concepts from the videos, audios, text, slides, contents to generate a short and easy understanding summaries and showing the exact key points required for that in that videos or audios, any multi-modal requests. So question and answer is like it allows the students or the learners to ask questions related to the lectures and also provide a step-by-step and a domain-aware explanations for the questions. And the feedback module, it gives the feedbacks like providing hints, corrections, and motivation responses and mimicking the support for the human tutors. And I have used the REST communication, which enables the secure communication between the modules. And it also ensures the scalability and modular integration between the modules. And next is the data storage, as it stores the process lectures, survey results, student process, and it also process both the processed learning content and surveys are stored in a relational database, which is enabling them to read and write operations for continuous improvement of the data. I have added the analysis engine, which analyze the behavioral learning behaviors and usage trends using the REST API. Like it gives the visualization modules, which gives the insights, like converting them into a graphs or charts or anything which can be easily understood, which gives them an easy way for understanding and giving the researchers to give the interpreted results. The generated insights are stored as in the insight storage, which is being like a storage database, which it enables the future system for the enhancement and improvement of the data. So this is the system architecture for the for my paper. And so the main key concerns and the privacy concerns for this is like showing the data access or ethical challenges like fairness or transparencies, which is being given in this. Addressing these sorts of concerns from the from the surveys data, I have tried to make it more secure by giving it a bias detection and human oversights and clear policies on the data usage and concerns. This data has varying levels of AI acceptance between the undergraduate levels to the postgraduate and also the doctoral levels, influence the factors of technology familiarities and academic demands. These are a few concerns which have been raised, and more than 110 valid comments for the survey. And the data provides a broad and representative view of students across various standards of UG or PG or doctorate level persons. So the survey was based on 30 questions. For an example, I have included 15 questions in that. The current usage of the AI, which is used in difficulty to study the subjects in engineering, as my present work is based on the engineering students, I have made it to engineers. So the familiarity with this AI education equipments, it may vary from different phases for each and every person. The readiness to use the AI tutoring system for studying and to improving themselves, and the willingness to use them is the most required thing. And most useful support in this AI tutoring, like do they require a video or an audio or in slide contents or text contents related stuffs? And why do they worry about the use of AI in studies, like their data privacies or their data sharing with us with the AI? Like those stuffs have been included, and we have got the results and the surveys, which will be shown in the next few slides. The usefulness of AI in making into a simplified notes and solutions, and most valuable features in AI tutoring system, effectiveness of AI in connecting the different engineering concepts and engaging with each and every engineering students or connecting the topics with it. The agreement that AI has improved the conceptual understanding compared to the traditional study methods like
Sorry to
a
interrupt
book.
you, ma'am, but you have 1 minute to conclude your presentation.
Yeah, I'm done. Okay. So this shows the summarization and overall satisfaction and likelihood of the recommendations of AI tutoring systems. So this is just few surveys and made with that. So I have got around 110 to 120 survey results from different persons, and I have got this. So the conclusion is like students increasingly they start preferring digital and online tutoring system over the textbook or interactive learning. So demand is like they require a strong need to convert the audio, video, and multimodal system. The benefits for the AI in education can make it simple, improve the concept and clarity, along with the accuracy and time saving, which can enhance the effectiveness of learning. The overall student response was in a positive manner with high satisfaction with AI tutors. So that's all. Thank you. If you have any queries, you can ask.
Fine, just one question. I think you
Okay.
might have considered a few more parameters to analyze the thing.
Okay.
And even the database part, you should have considered more survey kind of response rather than considering only 120 students and so on.
Okay, sir. I might have
And you
included
need to
those.
even consider few are having a knowledge of AI, few doesn't have having a knowledge of AI, and that way you can get the parameter impact in much better way.
Okay.
Right? Thank you.
Okay. Thank you.
Thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have Mugda to present the paper titled The Role of Big Data Analytics in Enhancing Digital Marketing Campaigns, a study based on customer perceptions and experiences. Are you there?
Yes, I am here. I
Yeah.
hope you can.
Yes.
Let me just put it in slide mode. 1 minute.
Yeah, we can see your screen.
Yeah, I'm just trying to put it in slide mode.
Yeah, sure.
Okay. Yes. Good afternoon, one and all present here. Me, Dr. Mugda Kulkarni, along with me, my co-author, Dr. Kanchan Patil, is here to present our topic, which is the role of big data analytics in enhancing digital marketing campaign, a study based on consumer perception and experience. Since we are seeing these days, there are many marketing activities which are strategies which are going on with instead of having a conventional method, they are everybody is using digital form of marketing. Now this creates a huge data. So this big data is analyzed using personalized marketing and superior consumer experience. This real-time data, if at all we track, it helps us to understand how to build a brand loyalty. We have used this concept in our research, where our research is offering a theoretical insight by combining technological focused and behavioral focused point of view for a practical implication for the marketers, which will enhance that trust, also increase the engagement and provide an ethical digital practices. Now, our study has many studies which we have gone through the review of literature are talking more on the technology aspect, but we here have also combined the behavioral aspect of it, which includes the customer loyalty, which includes the customer trust, customer engagement, customer satisfaction, and ethical practices. So coming to our research question, we are trying to see how technological and behavioral aspect of data analytics influence customer behavior, intention, and brand loyalty. We have also tried examining the influence of technological as well as the behavioral factors which will be on consumer behavioral intention in digital marketing, and analyze the mediating role of behavioral intention between data-driven marketing techniques and brand loyalty, considering demographic as a moderator. So we have used our underpinning theory is cognitive motivation emotion. This is the theory which we have used, in which cognitive part we have taken the consumer perception of data practices, which can be the usefulness or the privacy concern what consumer typically has. Motivation are the internal drivers or the behavioral intention, which are perceived benefit and the trust for the marketing advertisement, and emotional, which are the effective reactions which are linked to the data usage and the ethical standards. So coming to this part of technology factors in data-driven marketing, personalization, BDA, big data analytics enables customized content based on user behavior preferences, which increases relevance, engagement, and trust in a digital campaign. Some of the factors like data security, large-scale data application raises privacy issues. People have lack of trust when too much of data is collected during this process of marketing. There should be a transparency, so disclosing of data collection and use of which will help to use a confidence among the consumers, giving consumers a control over their personal data. When I'm sharing something, I know that the data is not misused. The behavioral aspect of it is data-driven strategies like interactive ads, predictive recommendation, AI chatbot enhances the engagement of personalized experience, positively impacting the behavioral intention. Customer satisfaction also increases digital marketing deliveries, relevant content, and seamless experience helps to meet the expectation. Ethical management of consumer data, GDPR is becoming very crucial because of the trust factor which is considered here. Customers respond positively to the perceived big data analytics, which enhances their experiences, taking a sustained behavioral intention. So when it comes to behavioral intention, the review says that the advantage of this big data analytics helps to enable the brands to understand more customer needs and facilitating the targeted promotions. So we come to this part, which is our model. This is our conceptual model, which is talking about technological part, personalization of content, privacy concern, and transparency and communication, which is technological part. Coming to behavioral part, it is customer trust, customer engagement, customer satisfaction, and ethical practices. Now, all these leads to behavioral intention, which leads to loyalty. We have kept a control variable, which is a demographic. The control variable is like a constant, which will help to understand the personalization in this brand loyalty. So hypotheses are based on our model. Personalization leads to behavioral. All the technological factors leads to behavior. All the behavioral factors leads to behavioral intention, which leads to brand loyalty. These are our hypotheses. So coming to the research methodology, this is our sample, which is taken from males and females with the age group. We have youth as more of our age group because of the marketing thing. So we have used PLS SEM as our and for our analysis, and all the factor loadings which you can see here are in our further statistics are according to the threshold level. So the statistics are, so our measurement model shows the reliability of the questionnaire is assessed. The reliability of our questionnaire is assessed using Cronbach alpha, which is greater than 0.7, and the validity of the instrument is assessed through the content validity and construct validity. So the table shows according to the threshold level. Hypothesis testing. So we have the hypothesis which were built. We have tested using the data, and it shows that all the construct which are positively supported. All the constructs which are positively supported, let it come to perceive customization and behavioral intention, or risk and behavioral intention, digital convenience and behavioral intention, or content trust and behavioral intention. Only one which is not supported here, if you can see here, this is the B6 one, is not supported, is the customer experience and the behavioral intention. It is not significant. It might be because the big data analytics more focuses on the objective or the behavioral data rather than the subjective part of it. So the psychology of consumer experience or behavioral intention are not adequately captured. It also might be because of big data analytics primarily designed to optimize the operational and the short-term performance of any outcome. So where it comes to experience or the behavioral intention are more towards a longer term, and emotional construct leads to non-significant relationship. So discussion, personalized privacy content assurance drives the brand value and which is required for the ethical practice. The trust also builds the emotional consumer brand relationship, and demographic part also, if you take, varies according to the customer demographic, requires a various different strategies if we are taking demographic as a control variable. So implications of our study is it focuses more on technological and the behavioral factors, cognition and affection and social aspect, influence consumer interaction with digital marketing. Technological factors drive acceptance or rejections. Behavioral factors based on the marketing campaigns also drive the brand loyalty, and the cognitive and emotional factors drive and has an impact on consumer decision and action. Thus, the paper sample primarily focuses on the youth is one of our limitation. So concluding, the big data analytics drives personalized marketing and superior customer experience. Real-time data tracking will be helpful to build a brand loyalty for an organizations, address privacy and privacy, transparency and ethical concern to maintain customer trust. This study thus explores the technological and behavioral factors impacting brand loyalty. And these are some of our bibliographic references. Thank you.
Just one simple question.
Yes, sir.
How your BDA probably differ from something like Tableau and Power BI? Because we are also going to explore the dashboard part, which will help us to even go for the future disease data. So how probably your study
So
differ
our
from
study
something
is
like
more
other tools?
on. Yes, sir. So our study is more on where we are trying to see the perception of the customers towards the big data analytics. The one which is already there are taking some quantitative data, and the which can be analyzed on Power BI. However, ours is a perception based, where we have taken a questionnaire and asked people age group from 15 to 18 to. Hello. So we have asked the samples.
Thank you so much.
Yes, thank you, sir.
Thank you so much for your presentation. So, I sincerely want to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ICTCS 2025. Before ending this session, I would like to take a moment to thank our session chair, Professor Bimal Patel, for chairing this session. So, this is a token of appreciation on the behalf of the whole team of Team ICTS and Global Knowledge Research Foundations and partners. Would you like to share a quick closing remark with us?
Thank you. Thank you so much for giving me an opportunity. Thanks a lot.
Thank you so much, sir, for your valuable presence. I kindly request everyone to kindly switch on their cameras for a quick snapshot. Thank you so much, everyone. Take care, stay safe. Thank you.